Back to your favorite intermediate algebra class. We're going to take a look today at the fundamental counting principle and permutations. So our objectives is to use the fundamental counting principles and use some permutations to solve problems. So here's officially the fundamental counting principle. Okay, if you got one event that it can occur in m different ways and another event that it can occur in n ways, then the total number of ways that both events can occur is m times n, and you can expand this to 3 or more events. You know, if you have another event that can do it p ways, and be m times n times p. I think this is best illustrated with an example here. Using the fundamental counting principle, you're buying a sandwich. Okay, you have a choice of 3 meats, you got a choice of 2 breads, and 3 cheeses. How many different sandwiches with 1 meat, 1 bread, and 1 cheese can you choose? So let's, you know what, first let's make this visual here. So you can have any of these 3 meats. You can have a ham, you can have a turkey, you can have a roast beef. Whoops, roast beef there. We'll do R. Okay. And off of each of these, if you pick ham, you could either have wheat or rye bread, right? Same thing. If you pick a turkey, you could have either wheat or a rye bread here. If you pick roast beef, you could have wheat or rye. Okay. Now, let's say you go with ham and you go with the white, oh, I'm sorry, white bread there. I should have read that closer. Let's say you go with ham and you go with the white bread here. Now you have the choice of 3 cheeses. Swiss, American, or pepper jack. Okay. Now, if you go with the ham, you go with the rye bread, you still have Swiss, American, or pepper jack. Right. If you go with the turkey, Swiss, American, pepper jack. If you go with the rye bread, Swiss, American, pepper jack. If you go with the roast beef and the white bread, Swiss, American, pepper jack. Anyway, so on. Okay. Okay. So like one sandwich might be I pick turkey and white bread and Swiss is my cheese, right? That'd be one sandwich, if you will. Okay. So how many you got? Well, you got one sandwich here. You got a second sandwich there. You got a third sandwich there, right? So you got three options: 6, 9, 12, 15. There's 18 different sandwiches that you could choose from with these options, right? So the fundamental counting principle says, how many different kind of meats can I choose from? Well, there's 3 ways to choose a meat, right? How many breads do I have to choose from? Well, I got 2 ways that I could pick a bread. I could pick either white or the rye bread. And then how many ways can I pick a cheese? 3. Swiss, American, and pepper jack. Okay, we just multiply those together. 3 times 2 is 6, 6 times 3 is 18. You see that? So that's the fundamental counting principle in action there with a little visual beforehand. All right, let's do some phone numbers here. The city of Las Vegas has an area code of 702. You know, I think they changed this. I think that there's a couple different area codes now, and in the state of Nevada. But anyways, you have an area code we're going to consider just 702, okay, for telephone numbers. How many different telephone numbers are possible if you can repeat digits? So let's write this out. Okay, so obviously our only options are 702 for the first one, right? So I only have one option for the first number times one option. I can only have a 0 there times I have one option for the third number, right? I'm fixing this at 702, and we're going to find the total amount of numbers that you can have if digits can be repeated anyways for the area code 702, right? Now this first one, after this, right? You have your like your dash, right? 702, whatever the first 3 numbers are here. You say, well, I can have anything between 0 and 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. I can have any of those. So how many numbers is that? I have 10 options, right? Same thing for the next one, 0 through 9. I can repeat, so times 10. Times I still have 10 options, right? So my phone number could be like 702 444 4444 kind of deal, right? You can repeat. So I have 10 options here. I get 10 options here. I got 10 options here. I got 10 options there. So what would that be? 10 to the 7th, right? 7 there. So I think that's right there. I believe 10 to the 7th should be 10 million. Okay. So you have, if you multiply 1 times 1 times 1 times 10, 10, 10, 10, 10, 10, 10, right? 10 to the 7th. So 10 million is how many total phone numbers? Total different phone numbers for area code 702, right? So if you think about that, so if your population, for a state is more than 10 million, like California's got like, what, 38, 40 million, something like that, they're going to have different area codes. You can't just have one area code. And nowadays, I mean, crap, people got like a million different phone numbers. It's not just they have a cell phone, maybe they have a house phone. Anyway, so there's multiple phone number possibilities for each person anyway. So, um, so 10 million total different phone numbers. Now let's consider this same scenario. See the second question here. How many numbers are possible if the last 4 digits cannot be repeated? So the last 4 digits cannot be repeated. Okay, I only have one option, 702. Those are my only options here. These ones can be repeated, right? So those are okay. I could go 0 through 9 through any of those. And then here, I cannot repeat. So I could do 0 through 9 here. But let's say I'd use the number, I don't know, 7, right? Now I can't use it anymore. So now I only have 9 options there. And then, so let's say the number was 7, 3, right? I've used both of those. Now I only have 8 options left here. And I got 7 options there. Okay? So that's how you'd set it up for if you cannot repeat the last 4 digits, right? You could also do the same thing if you couldn't repeat any of the 7 digits, if you will, right? But anyways, we got 1,000, 10,000, I should say, 10 to the 4th, times 9, times 8, times 7. So you got 5,040,000 is what this ends up being. 5,040,000 if you cannot repeat any of the last 4 digits, right? 5,040,000. So that reduced that significantly, didn't it? By almost half there, by not being able to repeat some digits at the end. Okay, 26 golfers are competing in the final round of a local competition. How many different ways can 3 of the golfers finish first, second, and third? How many different ways can they finish first, second, and third, right? So I say, well, how many different people, how many potential people could finish first in first place? I said, well, there's 26 golfers, right? And after that person's taken first, he's not an option anymore to take second. So I only have 25 options for second place, and then I got 24 options for third place, and you punch that in, and you get 15,600. There's 15,600, and this is an example where, order matters, right? First, second, and third. Order matters here. First, second, and third is different from, let's say, well, let's move on to the next one here. We'll talk about that. The permutation. All right. So definition here, permutation is an ordering of objects. Okay, so order matters, just like in that last example. The number of permutations of R objects taken from a group of N objects is denoted by N permutation R, NPR. Okay, and here's your equation for NPR right there. Okay, and permutation R. So order matters is what you want to remember on this. Order matters. Okay. Now you see the n factorial that is read, just like I said, n factorial, and it's a product of all integers from 1 to n. So if you remember this from like Algebra 1, like let's say on the top you had 8 factorial. Well, what 8 factorial means is you would just punch in 8 times 7 times 6, 5, 4, 3, 2, 1. You just multiply all that together. You know, if you had 5 factorial, well, that's 5, 4, 3, 2, 1. That's what it means. Okay? So that's what that factorial kind of remind you about that. Factorial. All right, so let's go back to the last example. We got 26 golfers. They're competing in the final round of a local competition. How many different ways can 3 of the golfers finish first, second, and third? So again, here, order matters, right? Order matters. And what do I mean by order matters? Well, if Joe finishes first and Sam finishes second and Devon finishes third or whatever, you know, first, second, third, that's a different than if it's Devon, Sam, and Joe, right? It's a different order. So this is saying order matters. First, second, and third. It's counted, right? Each different one is counted. So you say, well, if order matters, n permutation R, I have how many golfers? 26. I'm taking how many at a time? 3 at a time. Okay, so I have 26 factorial over, so 26 is my n, you see my n there, my r is 3, all right? So 26 minus 3 factorial. So this is 26, 25, 24, 23, 22, 21. Anyways, this keeps going. 3, 2, 1, right? Over, now 26 minus 3 is 23, so it's 23 factorial. 23, 22, 21, clear down, 3, 2, 1. Okay, you with me on this? So 26 factorial over 23 factorial. Now you notice, before I even punch this in, 23 over 23, 22 over 22, 21 over 21, all these cancel, 3, 2s, and the 1s. And you're left with 26 times 25 times 24, which ended up being 15,600 was the answer to that, okay? Now some calculators like our TI-89s, if you're working with a scientific calculator, they should have an NPR button. And on a TI-89, if you can find that, it's under the math folder. You go to the math, you go to probability, and then you'll see this NPR. And you just go 26, comma 3, and that'll spit out for you 15,600. Okay, but make sure you know the formula to get that like I worked it out there. Okay, so that's n objects taken r at a time. Permutations matter. All right, you were left a list of 8 chores and how many orders, okay, so order matters again, can you complete 6 of the chores? Okay, how many can you complete 6 of the chores? So you have n, p, r, n factorial over n minus r factorial, and we're saying I have 8 to choose from, and choosing 6, right? I'm doing 6 of the chores, so 8 factorial over 8 minus 6 factorial. That's 8, 7, 6, 5, 4, 1 over 8 minus 6 is 2. 2 factorial. So you notice that. So you have 8, 7, 6, 5, 4, 3. 8, 7, 6, 5, 4, 3. 20,160. 20,160. Okay? Or again, a permutation. A permutation 6. Okay? Now, what if you're doing all 8 of the chores? So part B. Okay? So 8, permutation 8. Again, order matters. What order are you doing these things, right? And how many different orders can you complete it? So 8 factorial over 8 minus 8 factorial. Okay? So you got 8, 7, 6, anyways, 8 factorial over 8 minus 8, that's 0 factorial. Now, 0 factorial is 1, if you remember that, okay? And on the top here, you got 8 factorial. And this 8 factorial ends up being 40,320. Okay, all over 1. Okay, so 0 factorial, your special case there, 0 factorial is 1. Okay, if you remember that. All right. What about if you have some kind of repetition here? So here's your formula for that, n factorial over, so you have like a one object's repeated q1 times, you notice you got to take out your repetitions. That's what this denominator is saying. I think you'll see that on this first example. Find the number of distinguishable permutations of the letters in mom. Okay. Oops, put that up here. So mom, let's do. Now, if you were to write this all the ways, you could do MOM, right? You could do OMM. You could do MMO, right? Those are your 3 ways. But this is saying, well, you know, if these were different, you would count that one, right? If M and M, if those were 2 different letters, wouldn't you count that? And if these 2 are different, wouldn't you have another one of these, right? You'd switch those, and if those 2 were different letters, you could switch those. You with me? But we can't recount those, right? So we really only have 3 ways to do this, okay? Distinguishable permutations, okay, to order these things. And so our formula is saying, well, n factorial, you got 3 ways, you got 3 of these letters, but I got to take out my repetition. So I have, you see how the m, I have 2 m's, right? So I got to take out 2 factorial. I have 2 m's, okay? I have 2 m's. Okay, m is repeated. How many times is it repeated? Twice. Okay, so you got to take that repetition out. So you notice 3 times 2 times 1, 2 factorial is 2 times 1. Oh, that's why you got 3 ways to do this. Okay, so the little formula there works, and it's nice when you got bigger and things with lots of repetitions, or you got a lot of events and so on. Okay, so let's do algebra. Everybody loves algebra. All right, let's do algebra. How many distinguishable permutations, how many different ways could I order the letters in algebra, right? I say, well, how many letters do I got? 1, 2, 3, 4, 5, 6, 7, right? I got 7 of these letters. But some of them are repeated, so I don't want to count those twice. So I say, well, looks like I got 2 A's, right? So I have 2 A's. 2 A's. So it goes there, right? Looks like anything else repeated? A, L, G, E, B, R, A. No, don't have anything else, right? So that's it. That's it. 7, 6, 5, 4, 3, 2, 1, 2, 1. So 7 times 6 times 5 times 4 times 3. And we got, ends up being 2520, it looks like. 2,520 different ways to order algebra. Okay? All right, one more. Mathematics, another favorite word. Some of you guys think this is a vulgar word, but just kidding. We love it, right? Mathematics. Okay, how many letters we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Take out my repetitions. I say, well, looks like I got an M and another M. Okay, I got 2 M's. 2 M's, right? If there were 3, I'd have a 3 factorial down there, right? Looks like I got a couple T's. Take out the 2 T's there. And I got a couple A's. A, right? So 2 A's. 2 A's. That was my 2 T's, right? Again, if I had more, like let's say I had 4 T's, I'd have a 4 factorial there. So that 2 factorial on the bottom, right? Okay, and I punch that in, 11 factorial. 11 factorial, and there's also factorial keys on your calculators as well, you guys. You can 9,916,800, and it looks like I got on the bottom 2 times 1 times, oops, 2 times 1 times 2 times 1 times 2 times 1, so we got an 8, right? 39,916,800, and this equals 4,989,600. 4,989,600. Okay, so 4,989,600 distinguishable ways that you can order the letters in mathematics. Absolutely fascinating. See you guys soon in class. Bring your questions.